If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip. The question we're working on today is, the matrix A is row equivalent to B. 1. Find the rank of A and the dimension of the null space of A. 2. Find bases for the column space of A, the row space of A, and the null space of A. So we want to find the rank of our matrix A. And we know that the rank of A plus the dimension of the null space of A is equal to the number of columns, which in this case is 5. The rank of A is just the number of pivot columns, which is 3 in this case. And then from the previous equation, we see that the dimension of the null space must be 2, because 3 plus 2 equals 5. To find a basis for the column space of A, all we have to do is look for the pivot columns of A. So the basis would be the first column, the third column, and the fourth column. And this is from A. So even though we use B to find the pivot columns, the basis for the column space comes from our initial matrix. The reason why I'm stressing this is because when we find the basis for the row space, we use the rows from the matrix in row echelon form. So here, the basis for the row space of A is the first, second, and third rows of B. And really, we could have picked any matrix in row echelon form that's row equivalent to A. And now the last part is we want to find a basis for the null space. So we need to get our matrix into reduced row echelon form. And so I did this calculation off camera, and we get the following matrix in reduced row echelon form. Now each of the rows of that matrix corresponds to an equation. The first equation is x1 minus 3 halves x2 minus 9 halves x5 equals 0. The next equation is x3 plus 4 thirds x5 equals 0. And the last equation is x4 plus 3x5 equals 0. And now we could solve for each of the basic variables, x1, x3, and x4, and plug it into and write out what our solution vector should look like. And now once we have our solution vector, we'll break it up in terms of the free variables. So it's x2 times the vector 3 halves 1, 0, 0, 0, plus x5 times the vector 9 halves, 0, negative 4 thirds, negative 3, 1. And these two vectors here form a basis for the null space of A. And you could check there's two basis vectors, and we said the dimension of the null space was 2. So that's one way to check your work. Make sure to subscribe for more Coffee and Math with Dr. Weselcouch. Don't text and drive. Bye-bye.